Okay, 5.7, example 11. So we're going to solve 6 cosine squared of x minus cosine of x minus 2 equals 0. So this one's already trinomial in form. So let's go ahead and let's factor this. And so I'm going to multiply. So I have cosine squared of x minus cosine of x minus 12. We know our first term, so we're going to have to multiply to give me cosine squared. So it's going to be cosine times cosine. And my last two numbers need to multiply to 12 and subtract to be a 1. So that's going to be 4 and 3. Bigger number's going to have to be negative. And they're going to give me a negative 12, so it's going to be a positive 3. Don't forget to bring back the 6. Now remember the rule. If it will reduce, you've got to reduce it. And both of these will reduce. 4 over 6 is 2/3. And 3 over 6 is 1/2. So I forgot my x there. And then the number on bottom goes in front of the cosine. So we have 3 cosine of x, I forgot my x on that one too, minus 2 times 2 cosine of x plus 1. Now some of you are like, do we really have to do that? Well, the goal here is not just to factor it. If I told you to factor that and it didn't have equal 0 on it, then yes, you have to move the number back in front. But otherwise, we will end up with the same answer. So if you skip this step that I just wrote right there, I won't count it wrong. Just know, like I've been telling you all year, if it says just to factor it, if it didn't have that equal 0 on it, then you would have to have these as the factors, okay? But that's not the goal of the problem. So again, we've got two things being multiplied, so we're going to set them each equal to 0 and solve. And go ahead and work on the second one. And after you do so many of these, hopefully you'll notice, well, we're kind of getting the same answers here. So you could go back and look at what your answers were. Where is cosine of x equal to negative 1/2? Well, we know cosine is negative in quadrants 2 and quadrants 3. Cosine is your x value, so in quadrant 2, where is your x value? A negative 1/2. And we know that that's at 2 pi over 3. And in quadrant 3, which angle has the x value, is a negative 1/2. And that's going to be at 4 pi over 3. Now, when we go to solve this other one, let's go ahead and do that. Oops, jumping ahead there. And so we're looking for where cosine of x is equal to 2/3. Now 2/3 isn't an ordered pair in my unit circle, but 2/3 is between -1 and +1 for cosine, which means these angles exist. They're just not ones that we have written on our unit circle. So we're going to use our calculator to help us find this. Alright, so if I'm looking for x, remember to find x, we're going to get rid of cosine, we're going to have to do the inverse cosine, okay? And so what we're really doing is we're taking the inverse cosine of both sides, which makes that cancel, and then the inverse cosine of this side. Now, but before you put that in your calculator, hold on. Because remember, cosine is a positive 2/3, and that's going to happen in quadrants 1 and quadrant 4. So, what's going to happen is when you put this in your calculator, it's going to give you that quadrant 1 angle. You're going to have to find that quadrant 4 angle using, sorry, my computer's making a funny noise there, using reference angles. Alright, so since everything else has been in radians, let's go ahead and let's keep this in radians. So in your calculator, type in radian mode, inverse cosine of 2/3. And it should tell you 0.841. Okay, now quadrant 4. Let's think about this. I'm going to draw a picture. I'm going to borrow some space over here. Okay, quadrant 1 has this as a reference angle, which is 0.841. In quadrant 2, that means that angle right there is also 0.841. So we are 0.841 from being a complete circle if we look at our angle going this way, okay? So remember, in quadrant 4, to find your angle, you take 2 pi minus that reference angle. Well, that means we're going to take 2 pi minus 0.841, and so we find our quadrant 4 angle to be approximately 5.442. And so there's quadrant 1, there's quadrant 4, and then we still have our other two answers as well. And so there's my 4 solutions for example 11.